To find the inverse of an equation, we're going to use the same technique that we use to find the inverse of a graph. When we find the inverse of a graph, we interchange x and y. To find the inverse of an equation, we do the exact same thing. So we write out our original equation, we use a y instead of f of x, and then we change the x and y, but we will rearrange the equation to solve for y. Once you've done that, for your final answer, if the inverse is a function, you can use the f inverse notation. If the inverse is not a function, we simply use y equals instead of writing f inverse equals. Let's look at an example of this. So for this first example, we want to determine the equation for the reflection of g of x over the line y equals x. Now our first question is, what is this actually asking us to do? We're trying to find the equation of the inverse. And how do we find the equation of the inverse? We want to switch x and y. And then solve for y. Let's do that for this example. So I'm going to start off by rewriting my equation. Instead of g of x, I will write it as y equals x plus 2 squared minus 1. To find the inverse, we will write this as x equals y plus 2 squared minus 1. And we want to try and rearrange to solve for y. Let's start by moving the 1 to the other side. So x plus 1 equals y plus 2 squared. Now, if we want to isolate that y, we first need to isolate the y plus 2. And we can do this now that we have the binomial squared being isolated by taking a square root of both sides of the equation. The square root of the left side of the equation gives us the square root of x plus 1. Keeping in mind that we actually have two possible square roots, so I'll put a plus or minus there. And that will be equal to y plus 2 on the right side. Next, we just want to finish getting the y by itself so we can move the 2 to the other side. So y is equal to plus or minus the square root of x plus 1. And then outside of the square root, we have a minus 2, which we moved over from the other side. That is our inverse. Now, because we have this plus or minus in front, our inverse is actually not a function. So I will leave it in the form y equals. All right, let's look at finding our domain, both for the original and for the inverse. G of x is a parabola. So our domain is all real numbers. I'll say x such that x is an element of all real numbers. But we do have a range. This is a parabola that opens upwards. So our k value gives us a minimum. And our k value is -1. So we say y such that y is greater than or equal to -1. Y is an element of all real numbers. Now let's think about our inverse. Our inverse is a square root function, and we do have a restriction on that because we cannot take a square root of a negative number. This tells us that x plus 1 must be greater than or equal to 0, or x must be greater than or equal to -1. So our domain for this is x, such that x is greater than or equal to -1. X is an element of all real numbers. We don't have any such restrictions on y. And again, because we have this plus or minus from before, we actually have both halves of the square root function. Remember, the square root function has a positive half, or with a negative sign can have a negative half as well. So because of that, we actually have all real numbers for a range. So our range is y such that y is an element of all real numbers. Now, can we take a moment to compare that domain and range? Hopefully we notice that the domain of the original function is the same as the range of our inverse. The range of our original function, the same as the domain of our inverse, just with the opposite variable, which makes sense. All right, let's sketch both graphs. We'll start with g of x. So g of x is y equals x plus 2 squared minus 1, which is going to be a vertex at -2, -1. So we'll start at -2, -1. We have an a value of 1, so we can go across one, up 1, across one, up 3, and that's pretty much all we have space for. Now the fastest way to find our inverse is just to take our x and y values and swap them. So you can draw the square root function and do both the positive and negative, but given that we have all these key points, why don't we use our key points? So we have a point at -4, +3, at -3, 0, -2, -1, -1, 0, and 0, 3. For the inverse, we just switch our x and y values. So point at 3, -4, 0, -3, -1, -2, 0, -1, and 3, 0. And let's sketch those in. Okay, and you notice we do get, this looks like a square root function that's positive. This looks like a square root function that's negative. Together they make a parabola turned on its side. All right, answering a few final questions about these. Is g of x a function? Yes. Is the inverse a function? No, because it does not pass a vertical line test. Therefore, we know that g of x is not a one-to-one function. We also know that by testing the original because we can see it does not pass a horizontal line test. But knowing that the inverse is not a function is also enough to tell us that. All right, an interesting question here. What is a restriction that could be put on the graph of g of x that would make the inverse a function? Now, think about our axis of symmetry here. If we only took the left half or the right half of that function, and then we took the inverse, that would give us half of this function. So pick one branch of g of x. For example, the right side. The right side would be this side of the graph here, and think about what x values would that be. If we look at our x-axis, what x values is that? That's everything where x is greater than or equal to -2. That would be the right side of g of x. And that would only give us half, then the inverse would be a function. Similarly, if we just took the left half, x is less than or equal to -2, that would give you the other half of the inverse, and it would also be a function by itself. Does that feel okay? Yeah. All right, let's look at one last example. Let's determine the equation for the inverse of h of x, where h of x is the square root of x plus 3. All right, we'll come back to this note afterwards. Let's just start with the equation. So let's write our original equation in the form y equals the square root of x plus 3. To find the inverse, we will switch x and y. X is equal to the square root of y plus 3. Sorry for the stray bracket. Let's get rid of that. All right, we want to try and get y by itself. We can square both sides of the equation so that x squared is equal to y plus 3. And then we get y equals x squared minus 3. Because our inverse for this is a function, I could actually also say h inverse is equal to x squared minus 3. How do I know that? Just because it's a quadratic, x squared minus 3. Now the catch here is when you get this equation for the inverse, let's think about what the inverse looks like. The inverse is a parabola with a vertex at 0, -3. It looks like this, approximately. But what did our original h of x look like? H of x was the square root of x plus 3, so it started here at -3, and it's actually just the positive square root. So if we don't restrict our domain for the inverse here, this inverse is too much. It's giving us both parts of the graph. We just want one part of the graph. So think about which part of the graph do you actually want? We want the part of the graph that, for example, gives us a point up here. That's going to be this part of the graph here. Just highlighting that to make it a little bit clearer. So for example, here is x is 0 and we have a positive y value. That's going to give us a point where y is 0 and we have a positive x value. So if we want the right side of the graph, what we want to do is say that x is greater than or equal to 0. Let's leave a note here for that. If we don't restrict the domain, we get an extra piece of the graph. We only want the right branch. So we want the case where x is greater than or equal to 0. So now let's put this together. H inverse of x is equal to x squared minus 3 when x is greater than or equal to 0. And we combine that to get our inverse. All right, that's all.